Hello again. In this 10 concepts to know about AI part 4, we are going to look at these 10 concepts: anomaly detection, recommendation systems, customer churn, anti-money laundering, predictive modeling, predictive maintenance, natural language processing, computer vision, image classification and object detection and segmentation. If you look at this list, you will see that this list is uh, various applications of artificial intelligence or machine learning. These various areas are listed here where the artificial intelligence is really proving to be best suitable technology to solve the problem in this domain. That's where it is. So we will look into in this presentation to see that what these things are, how AI is really helping them, helping these type of helping to tackle the problem in this space, and how AI is really solving these problems. So let's go and start with the very first one. And the very first one is anomaly detection. What is anomaly detection? So before we even look into what is anomaly, so anomaly is the identification of a rare observation, event, item, or occurrence in your data. Anomaly could be good, could be bad. Anomaly is just a something which is out of normal. So if you have a large data set about a system log, and you really try to look into that log, and you really try to identify if there is any spike in your IO, if there was any issue with a voltage or vibration from an IoT device, you could really look into and say if there was any anomalistic behavior or not. So that's where you really, it's a rare occurrence in your data. It also called outlier also. So anomaly detection means the similar to outlier detection. So you have certain outliers in your data. Why it is important? It is important because if you have outliers in your data and you are doing machine learning, you might be training wrong information to your machine learning model. That's the reason you really want to remove the outlier in one way. Second way, outliers could be something very problematic in your data. So for example, you have a financial transaction data and you want to identify if there is any fraudulent transaction, and that will be something out of norm. If somebody is really moving certain size of significant size of amount of sum in some very different way, that could be flagged as an anomalistic behavior. So you could see that outliers or anomalistic are very I would say domain dependent, what you really want to do. But detecting of these outlier is a really very important aspect. Okay, if we look into outliers in two different setup, we will try to understand why we really need to use AI behind it. Okay, so if you have two a column, for example, you have two features, name and age. And if you try to look into age, we really know that age has a min and max. There will be no person with 700-year age. So if you have a row which shows a number 700, you very quickly say, oh, this is an outlier. This can't be possible. Or if it is there, it means it's something wrong is there. Data has a mistake in it. So this is like very small feature set. Visual inspection will work. Even if you do a graphical inspection, you can do a software using that. However, with a small feature set, they might work. However, that's not happen in real businesses. The data sets are really very large and wide, super wide. In that scenario, these methods, they really do not work. That's why the statistical and neural methods are really required to identify an outlier or anomalistic component within the data. So what is the technology behind anomaly? Okay, what happens is that when you have a very large data set, you try to look into the distributions of those numbers. All the features, they have a normal distribution. You really know what range they are really going back and forth. And then you look into an outlier. The outlier will definitely have a larger probability distribution comparative to the existing ones. And once you find that kind of distribution, you can very quickly flag it, and that flagging down that particular record or observation will be considered as an anomalistic behavior, an anomaly in that data set. So that's how the outliers are really being detected. With that's in statistical machine learning. If we look into the neural networks, autoencoders are a very popular way to identify the outlier. We will be looking into autoencoders in much more details in subsequent part when we are talking about the 10 things in AI. So I will not talk a lot about here. So that was anomaly detection, and our next concept is recommendation engine or recommendation systems or recommender systems or engine. So what they are? So if you look into your surroundings, they are everywhere. If you are a Netflix user, Netflix or Amazon or YouTube, Facebook, Instagram, if you visit a physical store from a very large chain, their recommendations are everywhere. Netflix, they really give you the similar content which you might enjoy. Amazon will give you the similar item which you might buy. YouTube will give you similar item based on your likings. Facebook will try to recommend you friend based on your other friends connections or the similarity or proximity to a certain place where you've been there or you belong there. Instagram will give you recommendation based on what kind of images you like. Do you like a nature? Do you like a technology? Do you like dogs or cats or animals? Whatever you know, Instagram will try to give you recommendation based on that. Physical stores are very recommendations are there. They know that if people are going to buy a product A, they will try to keep the product to be very close proximity to product A. So because there is a higher probability if you buy a product A, you will end up buying a product B, which is very close to there. So that's why they keep the recommendations are everywhere. Recommendations, they give businesses a very higher added advantage over their competition. So what's the technology behind it? So recommendation systems are basically filters. They look into data set, they look into your historical interaction with all those items, and then they generate a behavior model, what you like, and based on that they recommend what could be the more relevant item for you. That's a technology behind a recommendation system. There is a lots of math, lots of statistics underneath going on, but that's a core technology behind recommendation system is. And these recommendation system, they could be two separate ways. One is like a most popular item among all users. So for example, if there is a movie, Oscar winning movie, that could be the top, it's almost used almost like by every user. The other way is to look into what is the most popular or item among a user like you. So there is a users which is a modeling is done where all those users are segmented into various groups, what kind of content they like. That's why they look into that similarity between users, then they look into what the similar items they are really looking into or they are really attracted to, and then the recommendations are made based on users and content modeling together. So very first one here is called content-based filtering. It means the similar items or content are recommended to the users who liked one or similar item. So if you are a user where you like a movie X, then the movie Y, which is very similar to X, will be recommended to you. It means that the content similarity was used here. It was not based on you. It was based on content similarity. If you like a soda which has a lemon flavor, then you will be given other lemon flavor soda as a recommendation to you. Second one is called collaborative filtering, where the similarity between the users, the consumers, and the content is checked, and then recommendations are made. In this collaborative filtering, they look into say, okay, what multiple users really like, and then they look into what's the similar items they have really common in between, and then they look into based on those similarity between users and the content, the recommendations are made. If the third users like a certain content which is also part of same similarity as the content, then the third content will be very much likable by user 1 and user 2. So recommendation systems are very popular. Okay, the third one is customer churn. The customer churn means customer is no longer associated with the business. It's also called customer attrition. So what happens is that these days it's very popular to have a subscription based services. All those businesses, you look into telecom, you pay your bill monthly, insurance, you really have utility insurance, your life insurance, your home insurance, your car insurance, variety of insurance, you pay those bills monthly. Banking is also, you go, there are certain things there. Entertainment, you are what have Netflix subscription, Hulu subscription, variety of movie websites, online shopping. So subscriptions are everywhere. And if a business they lose a customer, it's a very big deal, because in online business, when people are buying sitting at their computer, it's really very hard to understand who this person is. You really do not have a relationship as a person, but you do have a relationship as a consumer through the system. So it's really very hard to create a relationship if you do not know the person as face to face. So that's why in subscription based online systems, customer churn is a very important aspect, and it really impact overall business performance. And for that reason, the several businesses they really try to deploy solutions like customer churn, so they can identify the probability for a customer to leave the business in next coming days or month, so they can really act upon it and try to go and work with this customer. So and before the customer leaves, they can really come up with a better deal so their customer can stick with the business. Okay. And in this kind of scenario on online businesses, the future sale is really very depend on customers, because they really look into what's the past sale, and then based on that they really come up with the next a few month plan. And if suddenly there is a big spike in customer churn, that's really going to impact the sale, as well as a lot more different variables will going to impact as well. So customer churn is done in terms of technology various ways. So there is a predictive behavior modeling for the customer, there where they look into and see that what is the customer, what are the customer activities, and then they try to identify those things, because these businesses they also have the historical record where they really know who what when the customer left. So they have these signals where they know when the customer churn versus when the customer did not churn, and in that scenario they use these positive and negative signals in the data to build a customer behavior model that is the base for their predictability for a next customer who might churn or not. Technology is also applied with micro segmentation. So if the customers if the consumer is really liking variety of item, and if certain item is missing or item is not available, or item certainly really has lower acceptance rate, and then certainly customer will leave. So businesses they also look into the micro segmentation within the business and see that okay, what customer is really doing at certain item level or certain service level, and try to model that behavior at micro level. So you have multiple customer behavior model within the business aspect, so they can really understand even much more granular at much more granularity the customer behavior, so they can predict. The next item is a customer lifetime value, which is like to identifying what is a customer value. And in very layman term, if you are paying $50 per month to a service, uh, to a business, then it means an yearly you are paying $600, then your lifetime value at 1 year is a $600. And if you are associated with that business for a 10 year, then your lifetime value is a $6,000. So they really try to predict these lifetime values for the customer, and then they try to look into the model and say that higher lifetime value has higher probability to stick with the customer. And then there is a modeling can be done where in some cases the customers are given extra preference so that they can stay longer with the business. Customer loyalty models are also created, and that is very different than customer lifetime value, because it is possible a customer is much more loyal, however his or her lifetime value may not be very high. So they look into the customer loyalty model, and then they really try to understand, okay, if the customer is loyal but still there is not lifetime value is not high, still they can keep that customer, because they really try to have a steady business source of business from the loyal customers. Our next concept is anti-money laundering, or AML. In anti-money laundering is, before we understand anti-money laundering, let's understand what is money laundering. So money laundering is is a behavior where the bad guys they really try to move the financial they try to perform a financial transaction outside rules and regulations established by the government and financial institutions. So we all know that governments for every country, as well as the financial institutions, they really try to set these rules and regulations so the money is moved at based on certain rules accepted by everybody. However, the bad guys there, they really try to bypass these systems so they can really move the large amount of money for different causes which they really try to, you know, basically they really want to move, they want to do these kinds of transfers outside these regulations. So they really want to find, they really try to come up with creative ways so they can really use these financial transactions without these financial institutions or the governments can really identify them. So that's money laundering. Anti-money laundering is a way where you can come up with the technological solutions to figure out if there was any transaction which was outside the norms of rules and regulations. And if you look into just if you just understand this whole scenario, you will see that the billions and billions of people globally, they are really following the rules and regulations. Only a very small percent of population who is really spending their time or involved in these kinds of things. So the probability of happening these items or these transactions are really very small. And in order to identify them, you really need to look a very super large amount of data. It's like a needle in haystack kind of scenario. So building an anti-money laundering solutions is basically you really need to come through very large amount of data to really find a very few signals which really money laundering. That's the reason these kinds of entities, they really pass by, because there is no real-time solution built into where you can catch them while things are happening. You catch them when they are already happened. It means the transaction is already done, the money was already arrived there where it should not be. So anti-money laundering systems are really very important to build, and still the technologies are really coming into existence so that solutions can be built upon. The anti-money laundering is just a way to figure it out what these financial transactions are which are not part of rules and regulations established by these banks and government. And in that scenario, you really have a various technical solution. There is no one single solution available. However, a semi-supervised machine learning is very widely applicable in this kind of scenario. Semi-supervised, we have already learned, where a combination of supervised and unsupervised machine learning is used. So you really, in this scenario, if you look into financial transaction, we really do not know what a bad transaction is until we find out. So, but we still, we or bank really have some information about what a bad transaction really look like, whether it's a hacker is trying to hack through ATM system, or it's a criminal is really trying to launder a large amount of money from one station to station B. So all that signals where they are already labeled as bad, they are very small, but there is a large amount of data which is not really labeled yet. So combination of semi-supervised along with supervised and unsupervised is really very popular, where some signals, they really are labeled, and then the other, all the data has to go through with unsupervised way to group into in some criteria, whether they are good or bad, whatever criteria is really being used to group the information. Then labels are done. Then after labeling is done, then the supervised machine learning is used to identify the similar transaction which are part of that labeled, which we have done in step 1. Autoencoders based outlier detection is really very popular as an anomaly detection method. Reason is that because autoencoders is from deep learning, so you have ability to process very large amount of data in very short amount of time using GPUs. That's one way to look into. And then autoencoders, they really come up with a very smart way to identify an outlier within the given data, and that's for that reason the autoencoder based outlier detection is really very popular, because of the technology they use, and they have ability to come through very large amount of data in very short amount of time. Our next topic is predictive modeling. It's also called predictive analytics, predictive analysis, or forecasting. So prediction, is just, if you look into last 30 to 50 years, actually the predictive models were used by various businesses when they have a historical data, and then using the probability from statistics, they really can predict an outcome within the data models. Okay, they can really predict the weather. So that's a little very popular example of predictive modeling, where they can the different agencies worldwide, they really try to predict the weather. NASA is predicting for global, they really look into, but there are local stations, they really look into different weather patterns, and then based on weather patterns, they forecast about the crops, forecast about the availability of resources, the heat at certain area. All those things, they come within that norm. For the businesses, it's a different way to look into. People really want to predict what will be the sales in next month, what will be the yield in next cycle, if you have industrial setup. So there are so many business applications or for predictive modeling, and it's a very popular methods for businesses to have an added advantage, because if your predictive models are very good comparative to your competition, you really definitely have an added advantage. Okay, so for that reason, you really have a historical data set, and you, it's mostly, this is a time series data set, because that's why you really know that how the situation was at certain month, at certain week. So that's time series data sets are available for you, and depending on what outcome you are really trying to identify, you try to build a predictive model. So the predictive models are used to forecast an outcome at some future state or time based upon changes to the model input. That's another way to look into. You will say that if your production is X, what will be your sales? If the input, if the weather has a different parameter, or if the population, if the economy has a different parameter, what will be? So you can also look into the pricing. You can say, if we will sell at this price to this zip code, what will be our sale? Or you can change a different price and you can change a different zip code, then you will see that what will be the sale. So there are various inputs, you can combinations, you can really tweak them, and then you really want to know that what will be the model, what will be the results. So that's a statistical probability based modeling. And with the the advances in neural networks, the LSTM, which stands for long short term memory, models are very popular for forecasting. So people are start using the LSTM models, and they start to do a predictive modeling. It's a really very big area, and now the deep learning or AI is really trying to help and really build the very highly accurate models to assist the businesses. And it's all depend on how good your data is. If your data is very good, it's clean, and it's really has a lot more information to it, definitely the model will be have very competitive results. Our next topic is predictive maintenance. Predictive maintenance is actually the extension of predictive modeling into the industrial environment or industrial reason. So industries, they have machines, they really work, they work all the time, and if machine really goes bad, it really stop the production, and that's really the downtime cause several problems. You do not have production, there will be significant delay, there will be significant loss, you are still paying for everything else. So if there is a downtime, that's really cost a lot more to any industry. So if you have ability to predict when a machine needs to do the maintenance, you can really stop the downtime, and then you can improve the productivity. So what is the predictive maintenance? It's also, predictive maintenance is the system which really predict when a machine or a group of machines will require maintenance. So you can stop the production for a while, you can put together a maintenance system, and the machine is ready, good to go. It's a very important aspect for a smart factory and smart manufacturing, which is like everybody's really talking about. So a smart factory and smart manufacturing, they really take predictive maintenance very seriously, where they really feed all kinds of, they deploy all kinds of sensors, so they can collect a lot more state related information about all those different hardware and all those moving parts, so they have ability to even do much more accurate maintenance cycle for those machines. With the industry 4.0, again, the predictive maintenance is a really very top priority for all those industries. It's a very highly effective and cost saving. We already talked about it, because if you lower the downtime significantly, you can definitely improve the value, improve the production, improve the uh, outcome comparatively. Okay. And if we look into, there is a term called condition monitoring. Condition monitoring is a way where you can really have a real-time live system. Could be humans, could be machines, could be cameras, combination of technology which require a continuous supervision. And that's really cost a lot. It may not be accurate, but using predictive maintenance, where you are totally dependent on data, you really and if you have a very rich data, you have ability to identify when a particular component really required maintenance, and using that you can really remove the whole system of condition monitoring, and you can replace with predictive maintenance. So that's about predictive maintenance. Okay, our next topic is natural language processing, or NLP. It's very popular. If you look around these days, the applications of AI, deep learning, you will see the natural language processing is pretty much at the very top. Lots of work has been done. Very successful results has been really created. So it's really very popular field, and there is definitely a lot more potential using natural language processing with deep learning. Okay, so natural language processing is a subfield of artificial intelligence, and it's a technology which can really manage the interaction between computers and human. And natural language processing helps computers to understand, interpret, and manipulate human language, either written or spoken. So natural language processing is the technology which really makes these computers to at a very close at a very close proximity. At least they have ability to either read the text, interpret it, translate it. So if you are the example of Google Translate is a really very big example of that. It's really very accurate. It's available in almost like several tens of languages. I don't know the exact number, but translation and those models are really very highly accurate, and I use them very frequently. So definitely the NLP in certain areas has achieved a significant accurate performance. Some examples such as Alexa, Hey Google, Cortana from Microsoft, Alexa is from Amazon, and Hey Google is from Google. These are also the conversational interface where you are talking with these devices and you are asking us some specific question, not very general, but at least they are designed in a way that they can answer you a variety of questions, so they can understand the conversation part of it. They can understand, they can what you are asking. In some cases they have ability to detect the intent at a very high degree. In some cases they might not even understand at all, because they are still evaluating, learning all those technologies. Still they are in very early stage, but in some cases the results are amazing. So natural language processing is definitely making computers to be more and more closer to human with regard to understanding languages and speech. If we look into examples of natural language processing, we could see the text summarization, where we can use NLP to create a summary text from a very large amount of text. Sentiment analysis, it could be done also through NLP. You can understand positive or negative sentiment behind a text. very popular. And if you are looking into the businesses, the feedback from customers, whether it's a positive or negative, you have ability to identify, then take action. Topic extractions, you can train a model to understand what a content is about. So for example, you can train whether it's a news, whether it's a literature, whether it's a poetry, whether it's a news about world, news about celebrity. Once you have it, then you can run these topic extraction method on a very large sum of text, and it can give certain topics with higher probability rather than certain topics with lower probability, and that's where you could extract what really this information is all about. Then if you combine all these topics, you summarize, then you extract the topic, and then you sentiment analysis, you really have a very good understanding of what that the passage or paragraph is giving to the computer has the information about it. Name entity resolution is another example where you can extract certain information from a given text. It can understand whether it's a name, whether it's a location, it's a college name, or it's a business name, whether it's really this information is. So you just need to train, and there are some public model available which can really give you certain information just by applying your model on your text. So name entity resolution is also a very good example. I would say chatbot and conversational AI. Chatbot is a combination of various technology, but again, the NLP is really making these chatbots, improve in very high degree. Conversational AI, is just making sure that the computer can understand what you are saying, and it has ability to somehow get the intent behind it, what you really mean asking. you know so it's still very early stage, but at least things are progressing in a right direction. Automated question answering, where you can ask question, and then system is really trained to understand the answers or the most probable answer, and then it can give you top 5 answers it can find with the rating, so you could really understand that which answer is really best suitable to the question you are asking. So natural language processing was our topic which you just talked about, and our next topic is computer vision. Computer vision is a field of artificial intelligence to train a computer so they can understand and interpret the visual world. So we have cameras is already there, and the relationship with camera and computers is really very old. So now we are, and then those visuals were really being sent to computers last 20-30 years. However, now we are really approaching at 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 a at a place where we can build these knowledge base, and so that we can explain what these visuals are. And with the advances in deep learning and combining with a computer vision, computers are producing amazing results. That these autonomous driving, and the in the industrial space, the defect identifications, or those kinds of things. Just visual inspections. Those are very several areas where the computer vision combining with the deep learning is really producing a very high rate of business results. If you look into image processing, which is very popular, however, it's a really very basic and the primary task in computer vision. Basic in a sense, it's not a basic as a very general. No, it's a very early stage, very first one, a primary, but it has a very powerful. It has a very significance presence in the overall pipeline of computer vision. So computer vision, if we try to summarize it, we can say that computer vision enables computer to see, identify, and process, very similar to a human. In some cases, we do have ability to achieve the accuracy such as infant. So we can say that it's in infancy stage. In some areas, the computer vision combining with the deep learning is really achieve the results are similar to adults, the way the adults are processing the information and making decisions. So I would say it's a very promising field. Lots and lots of work has been done, and so many businesses are booming with the combining computer vision and deep learning, while other areas, there are lots of research is really being done, and results will be coming in the next few years to few decades. Autonomous driving is one area where soon, pretty soon, you are start seeing some of those results already available to general public to try at least. If we look into some examples where the computer vision and neural networks are really very popular and people are really exposing them to in a way so that businesses can really take advantage of it, we can look into these four, such as semantic segmentation, classification and localization, object detection, and the instance segmentation. In next two concepts, we will be digging a few of these definitions in details and learn about it. So our next topic is image classification and object detection. So what is image classifications? Image classification is a method to identify if a given image belongs to a specific class or not. That's like a definition. It's a supervised machine learning method which uses a set of labeled images to build a model first and then apply a model to classify. So you have a requirement where you really want to identify, so you already have a collection of labeled images. So for example, if you want to identify a chair, you really put together a big set of labeled images they belongs to chair, and then you really try to put together some examples which are not chair, and using these labeled images, a set of yes and no, true and false results, you really train computers to understand what constitute an object such a chair and what does not. And a model is really created, and once the model is available and it has it's achieved certain accuracy, now you can apply that model for the classification. So this whole process is called classification. And the localization is also related with the classifications, where you understand in that overall image where that object belongs. So in which local area, which is specific to that image, where that object reside, or where the image really there, and it can be shown through a bounding box. So that's why you could localize the area and say that this image not only has the class but it's also available at that. So if you are trying to do the face recognition, whether using computer vision or neural network, or computer vision and neural network, you can identify not only the face, but you can also identify the where the face in that image is. You can identify where the nose is, where the eye is, where is mouth, where is our ears, because you have ability to not only identify them, you can also localize them. So one thing we can understand about image classification is that with image classifications, you are identifying one class at a time. So if you really want to create learning, create understanding about a certain image, there are several objects are there, and this is just like a limitless. That if that image belongs to nature, there could be trees, there could be birds, there could be mountain, water, rocks, sky, trees, boat, there may be some hut. It's just limitless possibilities. So going through with the training one at a time and then really scoring is really very cumbersome process, and it's just like technically and feasibly, business wise, it's really not a feasible solution. So what you could do is that could be other ways to expedite this whole process, and that's where the concept of object detection comes. In object detection, the model is really trained for various classes, and when the scoring is done, it doesn't really know how many classes are there, but it's really try to identify everything in very fast speed, and it's identify whether it's found a boat, it's found a flag, it's found a card, it's found this, or it didn't find. So it's really try to look into that how many classes that model is really trained for, and if it's a 2000 to 200 to 5,000, depending on where was the training environment was and the training data set was given. But after that training is done, that model is really has ability to identify all those classes which is really trained for at really very fast time, comparative to the image or classifications we're really going through one after another. So our next and the last concept in this presentation is which is really started with object detection and the segmentation. So in object detection, we start with a fixed set of categories based on our objective and interest. because depending on where you are really applying, whether it's on nature, whether it's a scientific experiment, or you're really trying to look into a very certain restricted environment, so you really train the system for all those classes, and then you go from there. YOLO, which stands for you only look once, is a very popular algorithm for object detection. And there are some pre-built model available based on YOLO version 2, 3, 3 latest, where it has the ability to identify really like over hundreds of objects in the image. So object detection is a combination of detection and recognition of image. So it's detect and recognize, based on the trained class, and then localize it. So that's, it's also knows that where that image really belong to. However, if you have hundreds and hundreds of classes, and if there is a possibility, if hundred if from an image, lots of a big number of classes are identified, the bounding box is really try to overlap with each other, and it's just like very hard to understand where the object will be. Then the concept of segmentation comes handy, because what the segmentation is that the objective of segmentation is to identify the segmentation mask for identification for the object instead of bounding box. So if you are looking into an umbrella or a chair, then the segmented mask, which is basically the where the chair is, so that area is really being pointed out from the image. So that's really helps to identify. Even if there are multiple images they group together, it will be the segment will consist all of them. However, it's a much better way to identify the objects in an image rather than just having the bounding box for that reason. So both object detection and the segmentations, they are used together to produce results in business scenario. So if you are trying to put together a solution, you really try to use a deep learning, object detection, segmentation, and various other solutions coming out from computer vision, whether it's a practical or they are still in release stage, and you combine everything together to generate the business result. So that's all we covered in this presentation. We covered these 10 concepts. Started with anomaly detection, recommendation systems, customer churn, anti-money laundering, a predictive modeling, a predictive maintenance, natural language processing, computer vision, image classification and object detection, and finally segmentation. I hope you definitely enjoyed these sessions, because my objective is to give you some of the information. So if you are a beginner, if you are really starting your career in AI, that will really that gives a very good information for you. So I appreciate your time, and hopefully I will be seeing you in my next lecture. Thanks again.